Hello dear friends, welcome to today's video. In this video, we are going to study about the theories of origin of Earth and our solar system. So under this theory, there are many philosophers and many philosophers, many scientists who have proposed the theories. So these theories can be categorized into two parts on the basis of the time scale when it was proposed. So we can say one of the categories is the early or the classical theories, and the other one is the modern theory. Okay. So under classical theory, there are many theories, but some of the major and important theories according to like for the exam perspective is that one is the gaseous hypothesis of Immanuel Kant, and the second is nebular hypothesis, and the third is planetesimal hypothesis, fourth is tidal hypothesis, and the fifth is binary star hypothesis. And under this modern theory, we have one theory, that is modern nebular hypothesis, which is also called as the solar disk hypothesis. Nebular solar nebular disk hypothesis. And this categorization do not stop here. This categorization, even sometimes you will be asked that which of the theories are monistic theory and which of the theories are dualistic theory. So basically, the monistic theory means that there is according to the involvement of the celestial bodies, like this gaseous hypothesis, nebular hypothesis. Okay, these theories believe that there are one celestial body, like from the sun itself or the cloud, that have done the formation of the entire solar system. And other theories like binary star and tidal hypothesis, they believe that two or more celestial bodies were before there and they collided with each other, or the gravitational pull acted upon each other, and then there was some kind of movement happened in the solar in the space, and then the formation of solar system happened. So basically you will understand these things, this categorization, after studying all these theories together, and then we will move to the modern nebular hypothesis. So if you feel that to make the video faster, you can make it to 1.2x or 1.5x by going to the settings and then changing the speed. And also, if you want to jump to a particular hypothesis, suppose binary star hypothesis or modern nebular hypothesis, then you can also jump to that hypothesis very faster. From the comment section, if possible, I will provide the timing of the each theory. Then coming to the early classical theories, as we have seen, the gaseous hypothesis theory that was proposed by Immanuel Kant in 1755. He was a German philosopher. So his core idea was that he drawn some of his inspiration from Newton's laws. Okay, especially the law of gravity. Okay, so he drawn the idea. He proposed that the Earth and other planets formed from a primordial, slowly rotating cloud of cold and diffuse gas, which is nebula. As this cloud contracted under its own gravity, its rotational speed increased. Okay, and what was the process? The process was the increasing centrifugal force led to the formation of rings of matter, which then condensed to form the planets. The central mass was eventually became the sun. So basically, what he wanted to say is that the Earth is formed out of the cloud, okay, and which is called as nebula. So what kind of cloud was that? That cloud was, first of all, he mentioned that this was cold, not hot, and also he said that it was diffuse gas. Okay, diffuse gas means that kind of gas that spreads out. Okay, spreads out. It means that the cloud was cold and also the cloud was spreading from its point. Okay. And then what he said that in the second point, he says in the second stage that all these clouds they get contracted under its own gravity. And again he says that all these gases, all these particles inside the clouds that contracted towards the center and become smaller. Okay, the area becomes smaller because of its own gravity. Gravity acted in the second step here. Okay, I know after looking at this hypothesis, you will think that from where that gravity energy came, if it was not before there. Okay, because this is also one of the criticism of the theory. Okay, and then what he says that the but later on all this because during 1755 there was not such advancement in the fields of physics, in the field of science, so he could not explain the theories or the or any kind of core reason behind the gravity. But later on some scientists tried to explain all these theories, and even as like this theory build the foundation for the modern nebular hypothesis also. Okay, but during Immanuel Kant, that is 1755, he failed to explain all the sources of the energy for gravity. Okay, so what he said is that when because of gravity all the masses that was there they contracted and become smaller. They contracted, the gas contracted and it becomes smaller. It rotated faster. Okay, it rotated even faster. And why does this will happen? Why this uh, cloud will start to rotate faster? Because of the angular momentum, law of angular momentum conservation. Okay, it means that the angular momentum will conserve its energy when the mass reduces its size. So let me show you a video from which you can really know how this angular momentum conservation works. Okay, so that you will understand this concept that why if the clouds will fall into one place and become smaller, why the speed will start to increase and why it will become even violent at this point of time.
Skater does by going into a tight spin. I'm not a very good skater, so I'll use this turntable and a pair of hammers. I'll hold them out at arm's length so I get a nice large radius, and I'll set myself in a slow spin. I'm spinning around at a constant speed, and then I draw the hammers close to my body and I spin around very rapidly. As soon as I move them out, I slow down again. And I can repeat this as many times as I want until the friction of the turntable stops me.
So as we seen there, and as we have saw in the video that the mass, if the radius of the mass is very much larger, and if we compare it with a smaller mass of object, and once we have started already there was angular momentum. Okay, that the angular momentum means the object is already moving in angle, in a circular angle. Then if we will reduce the area, okay, the radius will be reduced, then what will happen? This will start to move even faster. Okay, and then this is the second stage. And what happens in the third stage? When this mass of cloud starts to rotate faster and faster and faster, what happens? The centrifugal force acts here. Okay, in the third stage, the centrifugal force acts here. What happens for why centrifugal force will act here and what is centrifugal force? centrifugal force means the force of moving out of the center. Okay, objects will move out of the center. As you have seen, when a firecracker or something like a potter's wheel will rotate faster and faster and faster. Imagine you have 4 to 5 pebbles inside the potter's wheels. Okay, and if you will rotate this wheel faster and faster and faster, and these pebbles will also rotate, what will happen? These pebbles will come out and it will fall away from the center. Okay, so this is what happens when some object rotate faster and the centrifugal force acts upon the object that is loosely kept inside the center. Okay, let me erase this. So what happened? All these things came out after the fast movement, and all these bodies, okay, all these celestial bodies, all these things later on cooled down, and the central mass became the sun. Okay, but the centrifugal force was not that much like exceeding the gravitational force of sun. That's why what happened is that all these matters, they get cooled down, okay, through the time after rotating around the sun, and then what happened, they became the planets, which is today known as the 8 planets we have in our solar system. Okay, but what is the problem in the theory is that because it was in the year of 1755, Immanuel Kant doesn't have that much of advanced physics, no, physics laws who wasn't there discovered yet. Also, no advanced astronomical physics also was there. So that's why his theory, his philosophy failed to give adequate amount of proof for the some of the physical phenomena, and get a lot of critics and questions. Okay, it failed also to explain the what it failed to explain the initial source of motion or rotation of the nebula. As I have said, the gravity, why it was already rotating, why it, when he said that it was a primordial object, primordial means present since the beginning of time. Okay, primordial means present since the beginning of time. Primordial object was there. Then why it will start to rotate? Okay, from what was the source of energy it started to rotate or for the motion, and also it could not explain the adequately account for the distribution of angular momentum of the solar system. Angular momentum of the solar system means what is the distribution of the angular momentum? I hope at this point you understand what is angular momentum. It is nothing but a momentum. Okay, momentum means movement, a continuous movement that not moves in a straight line but has a angle. Okay, it has an angle, it's not straight, it has an angle. So when something will move in an angle, at some point of time it will again reach to the center point. Okay, so this is the circular movement or the angular momentum. It is called as the angular momentum. Nothing much fancy in this. This is just that a movement that has some angle. Okay, so the rotation of the uh, celestial bodies. Okay, we can easily understand in this way that the rotational movement of the celestial bodies. Okay, so what is here the problem was, sun having much of the mass of the solar system still rotates very slow in comparison with the outer planets, okay, which rotates very fast. And this theory doesn't explain the any of the phenomena why it is like that, that outer planets rotate faster and why sun rotates slower. Okay, but later on some of the theories they evolved, and they stated that there are so many forces behind this, and we will study it in the next videos. And for now, I hope I am able to make you understand the gaseous hypothesis of Immanuel Kant. Let's get into the next hypothesis. The second hypothesis is the nebular hypothesis, okay, which is proposed by Pierre Simon Laplace in 1796. Okay, it is the year 1796, approximately 41 years after the gaseous hypothesis. What was the core idea? The idea was that Laplace refined Kant's hypothesis. He refined the hypothesis. He suggested that the sun was initially hot, rotating gaseous nebula that gradually cooled and contracted. So, what is the difference? He said the sun was already there. Okay, he said, but what Kant said? Kant said there was the cloud. Okay, but here he is saying there was the sun already there, which was already hot, not cold, and rotating gaseous nebula that gradually cooled and contracted. And he is saying that gradually cooled down, the sun gradually cooled down, and then it contracted. The gaseous nebula cooled down. Why it cooled down? After radiating for a lot of time, its energy loosed into the space, and then it cooled down. Okay, and after it cooled down, what happened? When something cools down, what happens? It becomes denses, it condenses, it contracts. So that's why the gases, the dust particles, everything condensed and come to the center. Okay, and as it contracted is spoon faster. Again the same thing, it was a very like big nebula that was contracted, and when it contracted again it spoon faster. The what the video I have shown you in the previous video. Okay, and then due to increased centrifugal force at the equator, he said at the equator of the sun, what happened? It said successive rings of materials. These rings then condensed to form planets, and the central part remaining mass became the sun. Okay, so the same thing is that he said that the rings formed out of the sun, and then these rings collapsed, cooled down, and the gases collided with each other, okay, condensed, and it become the planet. So here also, even after the improvement, the hypothesis still had limitations, because it didn't explain the initial heat again, that why sun was heat already, and the rotation of the nebula, and what is the energy behind the rotation of the nebula, as he said in here. And also it could not fully account for the distribution of angular momentum in the solar system. Again, like the sun has most of the mass but relatively small amount of angular momentum compared to the other planets. Okay, and it also didn't explain the specific number of planets or the formation of their satellites. Okay, that why it did not give any explanation about why there are only specific number of planets, like 8 or 9 planets according to that time. Why only this much of planets are there? So these are the limitations. This theory could not provide all this explanation, and it is important to know that now what are the critics or what is the criticism, because this is important in the perspective of your examination. Okay, so hope you understand this nebular hypothesis. If you have any doubt, you can comment in the comment section. Let's discuss the next hypothesis. This is the difference between the Immanuel Kant and the Laplace hypothesis. Okay, as I have said, the initial state, it was cold and motionless. It was primordial. Primordial means it was there still since the beginning of the time. Okay, and in the Laplace theory, it was hot and already rotating gaseous nebula. It was already hot and already rotating. And then origin, what is the origin? Generated by collision and friction of particles. Okay, what Kant said is that the nebula collided with each other, and then the friction started the heat. But what Kant said, Kant assumed to exist the heat from the beginning. Origin of heat generated from friction and collision of the nebula or the cloud particles. But he assumed to be it initially hot and cools over time. Okay, and then evolutionary process. What is the process? First, collision was there due to gravity. Okay, because of gravity, because he was like inspired from Newton's law of gravity. Then because of collision, heat happened. Okay, friction happens, and friction produced heat, and this heat then produced gas, and this gas rotation happens, and then rings, and then planet. But here cooling was there, it got contracted, then increased rotation, and then flattening rings and planet. Flattening, okay, this concept we will understand in the next video. Flattening means when suppose okay, I'm explaining it right now. Suppose there is a pot, and imagine a wet dough of wheat you will keep here, and you will rotate the pot. What will happen? This dough will eventually get flattened, right? This dough will eventually get flattened. Okay, it will form like a disc. So that is what it is saying, the flattening. And then primordial matter was solid and cold in the theory, gaseous theory, gaseous hypothesis, but it was like gaseous and hot in the nebular hypothesis. Okay. So coming to the planetesimal hypothesis by Chamberlin and Molton. So Chamberlin was a American geologist and Molton was a astronomer. And this theory was proposed in the year 1905. So what is planetesimal first of all? So planetesimal are countless small celestial bodies, okay, that is found in the space. Okay, it is found basically during the formation of star or after a supernova explosion. Okay, what is the core idea of the planetesimal hypothesis by Chamberlin and Molton? And remember, this is the year 1905. Okay, this was a binary star or a tidal theory. We can say this a binary star. It means two stars are involved, or a tidal theory. Tidal means the force of gravity. Okay, theory suggested that a large intruding star approached the sun, which was already existed, and then the gravitational pull of the passing star drew out a large cigar-shaped filament of materials from the sun's outer surface. Okay, so what he is basically saying is here that the sun was already there, and a intruding star which was passing by the sun. When it passed by the sun, what it did? It did pull a cigar-shaped filament out of the sun's outer surface. Okay, like this. Cigar-shaped filament out of the sun's surface. As the intruding star moved away, when the star moved away, what happened? The filament broke. Okay, this filament lost the gravity that was having from the star, and it broke into pieces, smaller pieces, which cooled and condensed to form planetesimals. So what is planetesimal? I have already said. These planetesimals then gradually accreted. So what is the meaning of accreted? Accretion means when the planetesimal, the small things, they collide with each other, they stick with each other, and they form a planet. Okay, the sticking of the planetesimal or the small celestial bodies is called as accretion. Collided and struck together to form the planets. Okay. What is the merit of this explanation? Was that it explained the formation of both large and small planets. Okay, as you can see, if the theory is saying a cigar-shaped filament came out of the surface of the sun, what will happen? As we know that the smaller planets are here, and eventually the bigger planets are at the near to the middle or the end of the solar system. Okay, so it explained the larger in the middle of cigar shaped filament and smaller at the ends of the cigar shape. Okay, it also offered a mechanism for angular momentum transfer, because the angular momentum problem was there in the nebular hypothesis and the gaseous hypothesis, that the planets move faster than the sun. But here this theory gives the explanation why it was able to explain, because it said that a star passed by, and because of that star all the celestial bodies or the planets, they get their angular momentum, okay, because of the gravity, and then they are moving faster, okay. So that is the theory, but this theory also has the criticism. The probability of such a close encounter between two stars is extremely low, okay. The probability of this happening is very very low, okay. And the material ejected from the sun would be very hot and gaseous, and definitely if something is coming out of the sun, then it must be hot and gaseous, and making it unlikely to condense and directly into solid planetesimals, and it could have evaporated, okay, because it have came out of the sun. But here he says suggest that it condensed, and he failed to explain why it would condense, okay. But in later on, in modern nebular hypothesis theory, we will understand why this condensed, because definitely all the planets that have came from the sun itself, according to the modern nebular hypothesis theory, which is widely accepted also, okay. But this theory did not have adequate evidence or adequate information about the condensation of all these planetesimals, okay. Moving to the next theory, tidal hypothesis. This theory was proposed by James and Jeans in 1919, and then it was modified by Harold Jefrey in 1929. The core idea of the tidal hypothesis was similar to the planetesimal hypothesis. Jeans proposed that a large intruding star passed close to the primitive sun. The process, the immense gravitational pull of the intruding star created a tidal bulge in the sun's surface, eventually leading to the ejection of cigar-shaped filament matter. This filament broke into pieces and condensed to form planets. Okay, it is similar with the planetesimal hypothesis. Like there was already our sun, and a intruding star passed by the sun, and this when this star passed or crossed, what happened, the a cigar shaped filament came out, okay. Cigar shaped filament, what is a filament? Filament is like that we have seen in our bulbs, okay. There is a filament is nothing but like a rope or shaped string of material that came out of the sun, and these filaments then condensed and then formed our stars, our planets. But Jeffery did some of the modifications to this. His theory is also called as the collision hypothesis. Jeffery suggested that there was a companion star to the primitive sun. Okay, he regarded sun as the primitive. Primitive means it is there since the beginning of time, and he said that there was a companion star with our sun. Sun was not only a star there; it also have another star with it, that is here addressed as the companion star, okay. There was also another star that is with the sun, and the intruding star collided with this companion star, okay. He did not just say it passed by the sun, but he suggested that the intruding star that collided with the companion star at some point, the debris from this collision acted upon the sun's gravity and formed the planets. And he said when this collision happened, what happened? The sun was there, and another, our companion star was also there. Okay, that's why this is called as binary, also binary or dualistic uh, theory, because there are two or three celestial bodies are there, and then another star which was passing by, what it did, it just collided with the companion star, and this companion star exploded, and some of the debris come out of this star. And when these debris come in contact with the gravitational pull of the sun, what happened? They started to rotate around the sun, revolve around the sun, and gradually they cooled down and they become our planets. And again, this has some of the shortcomings because the low probability of such stellar encounter is there, and the ejected matter would be extremely hot and thus highly dispersed, and making its condensation into planets difficult to explain. It does not explain enough that why all these things will not evaporate and just condense and become our planets. So these are some of the shortcomings of the theory that of the hypothesis proposed by Harold Jeffery also in the year 2000, sorry, 1929. Okay, and then comes the last hypothesis, which we say the classical hypothesis. It is the binary star hypothesis, which is propounded by H.N. Russel. The core idea was proposed that our sun was a part of binary star, the two stars orbiting each other. A third massive star approached this binary star. Okay, and this approaching star disrupted the binary system, leading to the ejection of matter from the original star, which then formed our planets. Okay, it seems like same as the Jeffrey's theory, almost the same, that there was a sun, okay, our sun, which also have a companion star with it, and they were orbiting with each other. Okay, so what happened? Another third intruding star came and it collided with one star, and that star destroyed. And then the sun was surrounded by the debris of the companion star. That okay, and then when time passed, this debris cooled down and become the planets of our solar system. And it also has all those shortcomings, like it would have disappeared, the gases would have uh, disappeared and all these things. But later on, the modern nebular hypothesis that proved that gave some of the like reliable examples, some of the reliable principles behind why all these things happened and how all these things happened. So let's dive into the third part, that is the modern theories and the nebular hypothesis. The modern theories incorporate the advancement in physics and astrophysics. The observational astronomy, the nebular hypothesis, is revised and refined from the and remains the most widely accepted model for the solar system formation. Okay, so the modern nebular hypothesis or the solar nebular disk model, widely accepted. This is the most accepted scientific model for the formation of the solar system. It is the most accepted and scientific model, including Earth. Not only the formation of solar, but also including the Earth. It builds upon the core idea of the older nebular hypothesis. It incorporates the modern understanding of gravity. Okay, here this theory gave a lot of scientific principles behind all these processes. One is the modern understanding of gravity, the angular momentum, and the accretion. As I have said already, the sticking of the materials with each other during the collision is called as accretion. Okay, origin of the nebula. So first of all, it addresses how the nebula originated. Okay, so it says that our solar system began as a vast rotating cloud of gas and dust. Okay, so what is the first stage? Our solar system began as a vast and rotating cloud of gas and dust. Okay, first was a nebula was there, like a cloud of gas and dust. Okay, and then often called the solar nebula, but it is called as the solar nebula. This nebula was likely formed from the remnants of older stars. Okay, like supernova remnants. What here they it is who proposed this modern theories? Okay, this is that many scientists come together, and this is widely accepted by many scientists. And there are also some of the like important scientists who gave and proposed some of the theories, but the credit does not goes to any particular scientist. Okay, so from let's come back to the supernova remnant. So what is a supernova remnant? So let me show you. Okay, a supernova is a powerful and luminous stellar explosion, making the Earth of the death of a massive star, the explosion and of a white dwarf. So, what is a supernova? Nothing but the explosive death of a star. Okay, when a star dies, what happened? It explodes, and after explosion, a lot of remnants remain there even after the explosion of the star. Okay, so this nebula was likely formed from the remnants of older star, that is the supernova remnants, which explains the presence of heavier elements. Okay, in the previous theories, they were only saying that light, like gaseous elements were there, and no one has pointed out there must be a heavier element like dust or other heavier atomic or molecular gas like carbon or oxygen that should attract for other lighter gases or lighter elements to form a matter that will attract the that will create the gravitational force, so which explains the presence of heavier elements. Okay, this supernova remnants, a disturbance might have triggered the its gravitational collapse. Also, what this modern theory suggests is that a disturbance might have happened or might have triggered the gravitational collapse because a nebula was there, so our solar nebula, the remnants of a supernova was there. But then what happened that they came together to form the uh, gaseous nebula, condense or come together. It suggests that a shockwave from a nearby supernova. Okay, another supernova explosion might have happened near to our solar system. Sorry, not solar system yet, but our solar nebula. And because of that thing, the shock waves would have transferred here, and the gravitational imbalance happened, and they came closer. Okay, and then collapse and disk formation. Under its own gravity, the solar nebula began to collapse. Okay, under its own gravity, our solar nebula began to, which was like somewhat like this, and then because of gravity, it collapsed. Okay, it formed to this. As it collapsed, it spun faster because of the conservation of angular momentum. Okay, and at as it collapsed, it spun faster, and conservation of angular momentum acted upon here, flattened into a protoplanetary disk and protostellar disk with a bulge at the center. Okay, it spun faster and flattened into a protoplanetary disk. What it is trying to say is that suppose this was the, like this is a dough of wheat, wet wheat, and we will keep it on the potter's wheel, and we will try to rotate it. Okay, what will happen when we will rotate it slowly? It will be in this shape only. But when we will rotate this wheel faster, what will happen? This thing, which was looking like a sphere or a ball, will then convert or take the shape of a flattened disc. Okay, it will get flattened. Okay, because the bulge will start from the center point, and then eventually it will become flattened. So that is what this theory is trying to say, that flattened into a protoplanetary disk. So what is a protoplanetary disk? Protoplanetary disk means it is a rotating circumstellar disk of gas and dust surrounding a newly formed star where planets are formed. These disks are crucial in the process of planet formation as the material within them coalesces to create planets, asteroids, and comets. Okay, so what is a protoplanetary disk? It is a rotating circumstellar disk. It is rotating, first of all, it is a circumstellar disk. Okay, and of gas. First of all, it has gas and dust surrounding a newly formed star. A newly formed star, it will surround a newly formed star, and it is of gas and dust, and it is rotating, and this dust is crucial for planet formation. All these dust are crucial for the planet formation as the material within them coalesces to create planets and asteroids and comets. And yeah, and this disk formed with a bulge at the corner. formation of the sun, the proto-sun. Okay, what is the proto-sun? The phase of sun before it became a sun. Okay, like the not so true fully developed sun. The vast majority of the matter accumulated at the center of the disk. Okay, so what it is trying to say, the vast majority of the center of the matter, the vast majority of the matter accumulated at the center, and as I have explained earlier also, and the lesser things, okay, which came out after spinning faster and faster, it edges of the disk. As the core became denser and hotter, nuclear fission reaction ignited. Okay, here it is saying that the mass, most of the mass, as we know, that 98% of our mass of solar system is inside the sun. The sun holds the 98 percentage of mass of the solar system. Okay, so when it has that much of mass, means a lot of gravity is there, gravitational pull is there, and because of this huge gravitational pull, all the matters they collide with each other. Okay, especially we know that our sun is form of hydrogen, mostly of hydrogen, that is about 90%, and of helium, that is another 7 to 8%, and other are like other materials like iron, and then zinc, and then oxygen, carbon, and other materials. But the majority of the sun is made up of hydrogen and helium. So when there is immense unimaginable amount of gravity that acted upon the hydrogen atoms of the hydrogen, what happens? Nuclear fusion happens in the sun. Okay, and this reaction ignites and leading to the birth of our sun. Okay, and this then became the um, uh, illuminating sun of our solar system. And then formation of planetesimals. Again, here we see the formation of planetesimal in the cooler and outer region of the disk, the dust. So if you want to know how nuclear fusion happens, see, here is a hydrogen atom, okay, and here also another hydrogen atom. Okay, this is deuterium and this is tritium. So because of immense gravity, this deuterium and tritium of hydrogen, they collide with each other, and in the collision what happens, all the, suppose there are 5 elements, they come together, and then again they react with each other and they separate, and what happens, the hydrogen becomes helium and one neutron is released, and in this process the process releases some of its mass, which is converted into energy, and this energy and this process radiates a lot of in the form releases a lot of energy in the form of light. Okay, so this is in simpler, like I try to explain it simply, the version, the nuclear fusion, very simply. Okay, so if you want to know what is deuterium, tritium, it will take a lot of time to explain, but nothing but it is basically the same composition of one like element, like suppose hydrogen, when it has 2 protons it is deuterium, when it has 3 protons it is tritium, and sorry, not protons but neutrons, but it has 2 neutrons or 3 neutrons, then deuterium, tritium, it's like that. But if it has the same number of protons, that is they have one number of proton with each other, which makes the difference is that the mass, the total number of neutron and proton, that is 3, and this is this has 4 number of like molecules, and the mass is heavier. So that is the basic difference. Like the carbon, one carbon which is that becomes the diamond, and another carbon, that is coal. Okay, so what is the basic difference in this? The chemical composition. Okay, the chemical composition is same, but the structure of the structure of the element is different. So that is the difference between the deuterium and tritium of hydrogen. And then the formation of planetesimals in the cooler outer regions of the disk, the dust grains, the ice particles collided and the stuck together. Okay, due to the electrostatic forces. Okay, again here it comes the electrostatic forces. It is nothing but the like negative and positive charge of the electrons and protons of the or the molecules of atoms. Okay, So what happens because of all this negative and positively charged, the positive will repel with each other, and negative will repel with each other. But when two one proton and one neutron will come together, that a negative and positively charged particles will come together, they will get collided with each other, which is also called as accretion, which we have already discussed previously. So these electrostatic forces make them to stuck together, and over time these grew larger kilometer sized bodies and called planetesimals. Okay, and then this is how the planetesimal is formed. How the planetesimal is formed? In the cooler outer region of the disk. Okay, so how the planetesimals are formed? In the cooler outer regions of the disk, dust grains and ice particles collided and stuck due to the electrostatic forces. Means this was the sun, and this was like a disk that formed, and some of the particles were there in the outer space of the disk, and because of the electrostatic forces, that the negative and positive charge of the particles, okay, of the dust grains and the ice particles, okay, they collided with each other and they stuck with each other, and later on when they condensed, they formed the larger kilometer bodies of planetesimals bodies. Okay, and then accretion and planetary formation. Runaway accretion. The planetesimals continue to collide and then merge through gravitational attraction. This process, especially initially, was rapid, which is that's why known as the runaway accretion. Okay, so what happens in the runaway accretion? What is why it is called runaway? Because it was rapid. That's why it was called was runaway. And why it was called accretion? It was called accretion because, as we know, the sticking of the planetesimal with each other. Okay, so planetesimal continued to collide. Okay, all the planetesimal they continued to collide, merged through gravitational attraction. They collided and merged because of the presence of the gravitational attraction, and especially it was rapid, it was very fast during the initial period. The terrestrial planets. Okay, now comes the division of planets, that why the composition of planets. The nebular hypothesis goes further and it explains the terrestrial planets. It says that the hotter inner regions of the disk, okay, imagine this is the sun, okay, and this is the inner disk, and this is the outer planets. Okay, these are the inner planets and these are the outer planets. Okay, although we do not have this number of planets, but still, like just for illustration, the inner region is only rocky and metallic materials could condense. Okay, because of the heat that produced by the sun, only rocky and linked to the formation of denser rocky terrestrial planets. So the rocky and metallic materials could only condense there. Okay, because of gravity of the planetesimals, they collided the materials. But what persisted there through the gradual pass of time? Only the rocky materials and the metallic materials. Okay, rock and materials and metallics, which is the form of Mercury, Venus, Earth, and Mars. Okay, that's why we have Mercury, Venus, Earth, and Mars in the very closer proximity of the Sun. The heat from the frequent collision and radioactive decay kept the early Earth molten, and because of the heat and radioactive active decay kept the heat of from the collision. Okay, Earth molten. It is an extra information about the Earth, and then it goes further about the like how our Earth evoluted and changed. And now we will come to the gas giants like the Jupiter, Saturn, Uranus, and Neptune in the colder outer region beyond the frost line. So, what is the frost line? Frost line, also known as the snow line or the ice line, is the distance from a star where the temperature are low enough for volatile compounds like water, ammonia, and methane to condense into solid grains. This boundary plays a crucial role in the formation of planets, influencing whether rocky or gas giants are more likely to form in a given region. So suppose this is the sun and this is the frost line and this is the our where our gas giants like Saturn, Jupiter, and Uranus are formed. Okay, and this is where Earth, Mars, Venus, and Mercury are formed. So volatile compounds like water, methane, and ammonia could condense into ice along with rocky material. That's why these are very big because it has rock, but also the condensation of gaseous materials and lighter materials happened here because it is outside of the frost line. And now we read what is a frost line. The frost line is far enough from the sun or the star that allows the volatile matters to condense. And this, if you have studied the composition of Uranus, Jupiter, Saturn, and Neptune, then you must know that it is mostly form of the cooler substances, that is hydrogen and helium, forming the gas giants. Okay, like Jupiter, Saturn, Uranus, and Neptune. Okay, and we have understood the first line. Now coming the differentiation. Okay, it says about the interior of the earth, how the different layer, what is differentiation? The different layers of the earth. As we know, as we have studied, inside the earth there are so many layers of earth. Okay, first there is core, then there is mantle, and there is crust, and all of these three layers also have smaller divisions inside it, and also it has very much different kind of composition. The core is made up of molten like magma, or we say that iron and nickel, and also the mantle and the crust has different composition. As the earth grew, it became hot due to the accretion and heat, radioactive decay, and gravitational compression. This heat caused the earth to differentiate, meaning heavier, denser, and materials like iron and nickel sank to the center of the core, while the lighter material formed the mantle and the crust. This process also led to outsizing, contributing to the early atmosphere. So you can see how modern nebular hypothesis explains the differentiation of layers of the interior of the earth, also for the builds the foundation for the for explaining the early composition of the atmosphere. And then here it comes the disk clearing. Means, as we have studied, there was sun and there was the disk. Inside the disk between the frost line there was some rocky and metallic planets, and outside some gaseous planets, gas giants were there, and also so many dust and other particles were there. But then what happened? Our solar system become clearer and visible and transparent. Why? How it happens? Because of the solar winds. Once the sun matured, it emitted strong solar winds which swept away the remaining gas and dust in the protoplanetary disk. Protoplanet, why it is again called as protoplanetary disk? Because it is not completely evoluted as solar system at that point of time, effectively ending the main phase of planetary formation. And when the solar winds swept away the remaining gas and dust, then finally the planets became visible. They got their shapes, and all the dust and particles, they got collided to the nearer planets, okay, and to the sun, and the our solar system became transparent, effectively ending the main phase for the planetary formation. And from here the planetary formation ended. Okay, so uh, thanks for watching the video, and in the next video we will discuss the relation with the Big Bang theory, and also for the formation of the earth and origin of the earth, and also we will like study other theories. So here we came to the end of about the origin of the theories, about the theories of origin of the earth. And if you have any doubt or any question, then you can comment in the comment section, or if you want any further topics to be discussed or any further difficult topic to be discussed here, then you can also comment that. Or if you want any changes, like changes in the language, like it should be bilingual, like Hindi and English, or even in other language, then you can also comment. And also like suggest me if you want some changes in the slide formation, like to keep the background white or to keep the background black. So whatever the suggestion, also you can comment in the comment section. Thank you for watching, and please don't forget to subscribe the channel to watch more videos, informative videos like this.